All right, so this section 7.5, using Euler's method. So just like we did before with the linear approximation, right, where we said y, aka the linear approximation using the tangent line, was equivalent to the slope, x minus x1, and then of course plus y1 if you moved it over. This is basically the same thing. We're just going to use this tangent line approximation multiple times in order to get to an approximation that is close to what we want. So an example, just to help us kind of see it a little bit better, there's a small animation right here that we're gonna look at. So right off the bat, you notice on the screen is a slope field, right? Once I press play, you're gonna see, not yet, yeah. So if you look at the y prime on the screen, it's equal to 2y minus 1. And we have our initial point that is on the curve is known to be 0, 1, where you see that pink point is. So when you're using Euler's method, you have your initial condition, which is 0, 1. We know what the exact solution is after separating and integrating. But when you don't want to do that, you basically have, and I'll show it on the other screen. When you have a step of 0.1, you're kind of finding these little tangent lines over and over again, okay? Now here, the blue line that is being currently drawn has a step change of 0.0005. So you can see it is very, very close to the exact solution, which is that green line that you see on the graph, for a long time before it starts having a larger error. So looking at this is basically what it is. If you have an initial condition, you find the equation of this tangent line. But obviously, if I wanted to find, let's say this is here, it's at 1, and I said I want you to let me know what is f of 2, right? There's a big gap here that's going to not let you give me the correct or accurate answer. But if you make a step change of, let's say, on this line, right, you move over just 2, and then you find the tangent line here. You notice that we are getting closer and closer to the actual function. And if you do it again, and then you find the tangent line, you might even be closer and closer. So the idea of Euler's method is basically to when the graph or the original curve is initially unknown, and then you have a starting point, then from the differential equation, using that slope, we can compute the tangent line. And then we take a small step along that tangent line to another point and find another tangent line. And then we take a small step on that new tangent line and kind of keep using these little tangent lines to hopefully get close enough to a approximation that is equivalent to the curve. And of course, the smaller the step change, then the better the approximation is going to be.